So there are three types of aqueous solutions that you will find. So before I go through those three types, I want to define what solubility is. Because an understanding of the definition of solubility is necessary to then define each of the three classes of aqueous solutions. So solubility is the max amount of solute that can dissolve in a given amount of solvent at a certain temperature. Generally with aqueous solutions, where you're dissolving a solid into water, increasing the temperature will increase the solubility. So you may have a solid that at a low temperature does not dissolve in water, but once you heat it up, it does. A good example of that is benzoic acid. I've used that in lab, and it's a pain because at a low temperature, it won't dissolve in water. You have to really heat that water up before the benzoic acid begins to dissolve. All right, so now with this definition, we can go through the three classes of solutions. So one is unsaturated. Right, this means that the solvent has the capability to dissolve more solute. So in an unsaturated solution, I can keep adding solute and it'll continue to dissolve. I haven't reached that solubility point yet. So say the solubility of a certain compound is 10 grams per 100 milliliters. If I only have 1 gram per 100 milliliters, that's unsaturated. 2 is going to be saturated. And at this point, the solution is in equilibrium with an undissolved solute. So going back to the last example, the solution would be saturated if solubility was 10 grams per 100 milliliters of water and your concentration was 10 grams per 100 milliliters of water. So that would be a saturated solution. Any more solid that you add in won't dissolve. And we say it's an equilibrium because there is still solute that's dissolving, but for every amount of solute that dissolves, you have, or for every amount of undissolved solute that dissolves, you have dissolved solute that turns back into a solid. So the rate of dissolving is the same as the rate of crystallization, right? And that would be going from a solute in solution to a solid. The third is going to be supersaturated. And a supersaturated solution is a solution that is saturated at a higher temperature and slowly cooled. So what happens now is your solute will remain dissolved even though it's above the solubility. So continue on the same example, a supersaturated solution may be you have 12 grams of your compound in 100 milliliters of water, even though the solubility is 10 grams per 100 milliliters. But if you cool it slowly, the crystals are not in the right orientation to be able to crystallize. However, if you accidentally knock the vessel holding the water, or if you drop a little tiny solid crystal into it, immediately it'll begin to solidify and crystallize. So all you need is a little disturbance of a supersaturated solution to then get crystallized solid. So those are the three types of solutions, specifically for aqueous solutions. And again, it's all based on the solubility of a compound and comparing the solubility of it to how much you've dissolved in a certain amount of water. And from that, you can determine whether it's unsaturated, saturated, or supersaturated.